So in the last video, we started with our basic implementation of the event loop, and we kind of got done with the main task queue and the execution part of it. If you haven't watched that video, I will link it somewhere you can watch it. And if not, then I'll just give you a quick walkthrough of it. So what we had was we created a class, we had a constructor which initialized the main queue, and then we had a function to add task to the main queue. And then when we start execution, and when we call this, we had a flag called this.running, which is set to true, and until the queue is empty, we keep on executing tasks one after another in a first in first out manner. And then once the queue is empty, we halt the running process and we exit the loop, right? So that's what. And then we just initialized it. We had this array of 10 elements, and for each element we kind of added a task to show is log, and that's what it did. So that's what. Now in this video, I want to get started with the microtask execution queue. If you don't know what the microtask is, so what happens is basically when there are some tasks in the main queue, sometimes it has some microtasks associated with that, right? So essentially what happens is when you are executing something from the main task queue, after you are done with that, you will look for the associated tasks that it had in the microtask queue, the next priority, before moving on to the next task from main task queue. So basically it's like a subset of tasks that are involved with one particular thing. Like we discussed, when you are placing an order, you might let's say you order spicy food and you might need water. So that act of getting water is not a explicit order, let's say, but it's kind of a passive order, right? So that you're placing a passive order of water, which is sort of a microtask associated with the spicy food that you bought initially, right? So that's what. So that comes under microtask queue, and we'll start implementing that here. So it's nothing different than main task queue. We had the main task here, we just copy paste it here, and we call it microtask queue. And instead of add main task queue, we just have it add task to maybe micro task queue, I don't know, micro task queue, and then we have this micro task queue. We push the task there, and then we start execution. What we do is we pick the main queue, we shift the task, and then we look for whatever is there in micro task queue for that main task, right? So we could have something like what to say, let's say the main task queue is there, and for each main task we have I don't know, let's see, so we could if we have something like if this dot microtask queue dot length greater than 0, then we can just execute whatever is inside there. For dot shift, execute the microtask, but this will also run in another loop on its own. So when when the main task is going on, after the main task is executed, there will be some microtask there. So it will be kind of a similar situation that is going on here. So when microtask length is greater than 0, we do while, maybe, I don't know. So while microtask length is greater than 0, so whenever it has there are elements in a microtask queue, we shift and we execute the task. So yeah, that's what. So let's see what happens now. So what's gonna happen is when we define some when we add task to the main queue, at the same time what we do is we add task to the microtask queue as well. So what we would do is my event loop dot maybe add task to microtask queue. Let's do this. Console.log task in microtask queue, and maybe we do, I don't know, that's it. So now if we run this, so you can see like first it ran the main task, then it ran the micro task. So if we do something like we added two things in the micro task, let's say, then what happens? So as you can see, it ran the main task, micro task, main task, micro task, and so on. So it keeps on going, right? So for every main task, it will run the micro task associated with that. So you can have random numbers of micro tasks as well. So let's say it's not necessary that every main task will have only two micro tasks or anything as such. So what we can do is, let's say we have I here, and yeah, I mean not that necessary. Yeah, let it be. So that's the example basically. So what goes on is, for every task it will have some micro task, and after running the task it will move to the micro task, and then it will move to the next task, and then it would move to the micro task. So that's how it works. But one fun thing here is, even one microtask can add a microtask. So if that makes any sense. So it's not limited to the main task to call something a microtask can also call something a microtask. So that leads us to this infinite loop kind of situation. So let's say we have something like this, right? So let's say we have const initialize microtask, and then what we do is we have I as some index, and maybe default value is 0, and inside that function what we do is yeah, similar. So what we do is let's say, yep, the same thing. So what we did was we added a set timeout. I don't think we need set timeout here, leave it. This is fine, this much is fine. So we just do executing microtask, maybe executing microtask, we do I, and then we initialize another microtask with I plus 1. So it is kind of a recursive pattern which will keep on calling itself with no exit condition. So like it's an infinite loop basically, so infinite recursive loop. So now if we by mistake do something like this, let's see what happens. Sorry. What did I miss? Oh, my bad. Yep, that's what. So you can see it's an infinite like row of microtask associated with task 1, I suppose. The logs got lost, I think. So the main task is stuck. The event loop is stuck in like solving the recursive microtask, which is like initializing one task within a microtask, and then that's doing that thing again, and that's doing that thing again. So it's like this infinite loop of creating infinite number of microtasks, and basically the main queue is blocked now. So until it finishes the microtask, it won't move on to the main queue in this use case. So I mean, that just says just being useful while using this, that would help, because this is, I think, yeah, this is doable. It's like a microtask can initialize a microtask or set up a microtask for execution. So if it's basically one microtask comes, its task is to add another microtask in the queue, that goes, adds another, that goes, adds another. So it keeps on running on this deadly infinite loop, which you will never be able to get out of since there is no exit condition. So we could have also added an exit condition, like let's say if maybe I equals to 100, do nothing. I don't know. Let's say if I not equals to 100. So when it's not equals to 100, then we do this. I don't know. Let's see what happens now. So this formatting is messed up. And we initialize microtasks, and let's make it smaller. It will be huge. Let's make it 10. So we have an exit condition in the recursive loop now, and then if you run this, we get this, which is pretty decent. Like it had an exit condition, then it exited of the microtask queue, moved on to the main task, next task in the main queue, executed the microtask for that main task, moved on to the next one, executed a microtask, and this is how the event loop keeps on running until everything is done and dusted, and it exits. So basically when nothing is in the queue, it's done. So this is how the microtask queue functions. Basically this is the basic implementation of it. Then again, I said it before as well, so why are we implementing it? To understand the minute details that we might miss while we are studying it theoretically, right? So if you were studying it theoretically, you won't be able to explore this condition. So this is completely doable. So it's mentioned in the if you want, like if you are into Mozilla docs and stuff, the stuff that are write about JavaScript and also you can have a look at it there as well. But this we kind of derived after implementation, right? So this is like, okay, so can we do this? If it's doable, then is that a problem? So that part of it, right? So that realization thing, it comes up if you just like sit down and jot a basic implementation out of it. So that's my basic purpose of going to this implementation. We are not in any way trying to create the event loop. Just to understand it better, we are trying to define the code for it, just to kind of simulate the same behavior that we might get and the complexities that might come with it, right? So yeah, that should be it for this video. If you like this video, drop a like, drop a comment. If you have any feedbacks, leave the feedbacks. I love to make videos on anything else that you'd like me to talk about. And yeah, that's it for now, I think. And then next video we'll start with this WebAPI thing, and we would try to emulate the async function behavior by writing some similar code, and how this would affect our simulation of an event loop. So yeah, that should be it for this video, folks. Bye, see you.